The air above the Reich was a realm of brutal, oxygen-starved silence, a place where metal failed and men froze. At 25,000 feet, the sun was a distant, hostile pearl. Inside the thin aluminum shell of his cockpit, every breath Jack Reynolds pulled through his mask tasted of liquid frost. His gloved fingers, white and clumsy, wrestled the control stick, responding to the sickening, subtle whine of stress that ran through the airframe. Then the silence shattered. A twin-engine Messerschmitt Bf 110, massive and menacing, punched through the haze below, closing the distance with predatory speed. Jack slammed the stick back into his gut. Instinct took over. He pulled the P-51 Mustang into an impossible, screaming vertical climb, higher, thinner, into air that should have been lethal. This was the altitude where the war machine died, where the thin atmosphere choked standard engines, turning horsepower into a desperate asthmatic wheeze. But not this Mustang. Not today. Instead of choking, the Rolls-Royce Merlin engine under the long nose roared, a smooth, impossible surge of power. It climbed past 25,000 feet, defying physics, pulling Jack into an untouchable blue sanctuary. The enemy pilot, desperate to keep the kill, followed the maneuver. His Bf 110 struggled for 5 agonizing seconds, its heavy airframe shuddering, before the engine sputtered, quit, and the Messerschmitt tumbled away, a dark, helpless stone falling back into the European haze. Jack let out a ragged, freezing breath, a sound half-laugh, half-shock. His heart hammered a brutal rhythm against the rubber of his mask. This wasn't standard operating procedure. This Mustang was a ghost, an advantage that should not exist. This edge, this impossible high-altitude performance, wasn't forged in a factory or approved in a Washington office. It began far below the cloud line, in the freezing, mud-soaked chaos of East Anglia, England. It was a result of one man, an American mechanic, who looked at regulations and threw them onto the burn pile. This is a story of a single, brilliant act of engineering rebellion that transformed the most crucial fighter of World War II, saving lives and tipping the balance of air superiority. The official narrative was one of flawless victory. The propaganda machine of 1942 sold the American people a dream, the P-51 Mustang. Sleek, fast, and married to the power of the British Rolls-Royce Merlin engine, it was hailed as a definitive answer to the Luftwaffe. Official reports designated it Invincible. Training manuals celebrated its revolutionary engineering. But down on the ground, inside the mud-choked, wind-lashed airfields of East Anglia, perfection was a lie. The Mustang looked deadly on paper, but the cockpit was where the truth lived. In warm weather, at low altitude, the Mustang flew beautifully. But in real combat, at 20,000 feet and above, in sub-zero cold under full throttle pressure, pilots and mechanics discovered the P-51's hidden, fatal flaw. The crucial cooling system was a catastrophic liability. The signature belly-mounted scoop, designed to ram high-pressure air into the radiator, allowing the engine to run at full power. Engineers had chased perfection, even flirting with generating thrust from the airflow itself, the theoretical, elegant solution known as a merited effect. But in the brutal laboratory of the sky, theory dissolved. The system was finicky, demanding flawless conditions. If the airflow wasn't perfectly clean, the temperature gauges didn't just climb. They shot into the red zone. Pilots reported catastrophic overheating during crucial climbs. In the coil violence of a dogfight, the engine would scream its warning, throttle back, or burn out entirely. In the winter, the cold brought its own malice. Cool it off and froze solid in the lines before the engine could properly warm. And the pressurized cooling loop? If any part failed, it didn't take long for the engine to seize or burst into searing flames. But the official doctrine filtering down from command was a steel cage. Asterisk, do not modify the aircraft. Do not question the design. Follow procedure. Asterisk. That rigid answer was an insult to the gut instinct of Melvin Harper, a 33-year-old staff sergeant from Tulsa, Oklahoma. Everyone on base called him Texas. He was a lanky, soft-spoken phantom in grease-stained coveralls. His hands were not soft. They were steel vices, and his mind was a perpetual engine of skepticism. Before the war, Tex hadn't studied engineering techs. He'd spent his life tuning flathead Fords, drag racing down dust-choked farm roads. He respected machinery intimately. Rules? Not so much. Tex was assigned to a fighter group huddled in a former Royal Air Force field outside Cambridge. Cold, punishing wind screamed to the open hangars, turning the concrete floor into a frozen sheet. Tex and his crew worked brutal 12-hour shifts, sometimes longer, battling frost, wind, and mud just to keep the P-51 Mustangs flying. But something began to haunt him. It was a sound, that distinct, hollow metallic groan the engine made when it strained, climbing hard at high altitude. Tex hated that sound. Then came the damning evidence. Temperatures spiking, coolant systems demanding impossible repairs. More than one Mustang returned with its belly scorched under the cowling, or simply vanished forever. He read every manual, cross-checked every specification. Then, one frigid December night, after yet another overheated P-51 limped home, Tex crouched alone beneath the fuselage, the beam of his flashlight fixed on the massive radiator scoop. He began asking the blasphemous questions the designers ignored. Was the scoop's angle wrong? Did the airflow fail to compress the way the blueprints promised? And what if, by subtly reshaping the duct's interior geometry, he could force the radiator pull air more efficiently, cooler, cleaner, more reliably? Officially, he was obligated to log the issue and wait for a mythical engineering update from stateside. But Tex had buried two friends that week. He would not wait. He made his decision. The next morning, armed only with scrap aluminum, a searing welding torch, and the hardened instinct of a man who understood pressure better than any textbook, Staff Sergeant Tex Harper committed insubordination. He asked for no permission. He filed no report. He just got to work. In doing so, Tex triggered a quiet, unauthorized revolution, an essential unapproved hack that started not with general strategy, but with a greased idea of a staff sergeant who felt the problem deep in his gut, in the straining sound of the engine, in the damning red trace of the temperature charts. Atmosphere. The problem wasn't paperwork. It was physics. Tex Harper, a crew chief who spent more time listening to engines than listening to officers, knew the official cooling schematic was a lie drawn in a warm office somewhere far from the frigid reality of 30,000 feet. The standard system wasn't just underperforming. It was strangling the legendary Mustang. Tex wasn't waiting for brass to issue a frustrated complaint or compile a useless AR. He rolled up his sleeves, retrieved the only tools he trusted, a heavy-duty hacksaw, a compressed air rivet gun, and a lifetime spent understanding how air behaves when pushed too fast. This was an act of unauthorized engineering, flirting openly with a swift military court-martial. He began with surgical precision, dropping the lower access panel beneath the P-51's belly scoop. Inside lay the heart of the crisis, the radiator duct. This duct was designed to funnel high-velocity outside air through the radiator and exit the rear, creating a pressurized flow. On paper, it was perfect. In reality, Tex saw turbulence, waste, and resistance. He saw the theoretical ghost of the merited effect, the whisper that if airflow was compressed precisely, it wouldn't just cool the engine, it could generate a small amount of jet-like thrust. Engineers at Rolls-Royce had flirted with this concept, but it had never been fully weaponized in a combat aircraft. Tex hadn't read their equations. He didn't need to. He understood high-speed airflow, the way a sculptor understands clay. What he saw inside that scoop made him physically shake his head. Joints misaligned, sharp corners creating drag, and zero smoothing to guide the high-pressure air where it needed to go. The duct was acting like a brake, not a booster. So Tex went to work. He scavenged thin, polished sheets of aluminum from a derelict wing panel. He meticulously cut and shaped a series of internal vanes, angle plates that gently narrowed the passage. This wasn't merely reducing drag. It was forcing the massive column of incoming air to compress violently before it reached the radiator matrix. He smoothed every edge, sealed every seam with adhesive resin, and riveted the custom duct system into place, ensuring every modification was invisible from the outside. He told no one. He logged nothing. He didn't even risk a whisper to the man scheduled to fly the heavily modified aircraft the next morning, Lieutenant Jack Reynolds. Reynolds was young, sharp, and possessed the exact amount of reckless confidence required to push a Mustang past the published red line. When Lieutenant Reynolds climbed into the cockpit, He assumed he was flying a stock machine. But 30 minutes into his high-altitude patrol, the radio crackled with disbelief. Birds climbing smoother than ever, Reynolds reported. Temps holding steady. Tex, did they put a new engine in this thing? Tex didn't answer. He just smiled. The results of that first flight were undeniable. Engine temperature at 25,000 feet was down by a stunning 15 degrees Fahrenheit. Acceleration during the climb was noticeably, violently improved. Lieutenant Reynolds claimed the plane felt tighter, more alive. He didn't know why, but he knew he wanted it again. Tex didn't slow down. Over the next 2 weeks, operating under the cloak of night and the cover of routine maintenance, he applied his unauthorized modification to 6 more Mustangs. Each received a bespoke duct system, refined based on performance data from the last. He reduced drag further and perfected the sealing methods. The impact resonated through the squadron like a shockwave. Planes receiving the Tex mod climbed faster, flew cooler, and suffered fewer mechanical failures. The pilots started calling them the Hot Ones, Texas planes. Unofficially, the commander turned a blind eye and gave the Maverick crew chief the silent green light. Officially, the modifications never existed. There was no authorization, no official decree, only results. A ghost protocol spread through the maintenance bays. Other crews noticed the tailored cowling scoops, the subtly altered geometry. Techs from neighboring squadrons began their industrial espionage, leaning in close, murmuring requests. Hey, mind showing us what you're doing with your scoops? Under the weak, yellow lights of the hangars, mechanics began nocturnal rituals, slipping in past curfew. They measured duct angles and sketched a radical design onto crumpled cigarette packs, their pencils smudged with oil. The modification was wildfire, a rebellion whispered across the tarmac. No one dared file an official complaint. After all, the pilots, the men who lived and died by these machines, had a ruthless motto. Anything that brings us home alive is worth keeping quiet. Tex, the quiet engineer, knew he was standing on the precipice of disaster. He wasn't just adjusting military hardware. He was fundamentally altering it during wartime without formal approval. Discovery meant disgrace. He faced emotion, or far worse, a swift and brutal court-martial. But for him, this wasn't about regulations. It was about raw, desperate survival. The turning point exploded in mid-February. Captain Roy Red Lansing, one of the base's premier aces, flew a mission deep into occupied France in a newly modified Mustang. High above a shattered landscape, Red was jumped. 3 snarling Focke-Wulf 190s, the butcher birds, slashed at his tail. For 10 brutal minutes, Red pushed his aircraft past breaking point. He outclimbed one German, he outdove another, and he managed to limp home, the fuselage riddled with holes. Yet the critical fact remained. His engine temperatures ran stable, holding the line the entire time. Red didn't waste a moment. He landed, killed the propeller, and strode straight into the hangar. He looked Tex in the eye, the adrenaline still vibrating in his voice. You saved my life up there. Whatever you're doing, keep doing it. Word reached the higher echelons within days. It didn't travel through formal memos, but through the vital intelligence of pilot debriefs and cryptic ARS. Suddenly, senior officers weren't asking questions. They were demanding answers. Asterisk, why are your planes lasting longer? Why are your engines defying specs? Why are your top pilots requesting the same 6 tail numbers every single mission? Asterisk Tech's new investigation was imminent, but by then his silent rebellion had already become a quiet revolution. The Mustang was evolving. What began as an unsanctioned tweak had taken on a life of its own. Within weeks, Tex Harper's cooling modification was no longer a rumor. It was a movement. Mechanics across the base raced to replicate his work, comparing flow results and swapping secrets over bitter coffee in drafty hangars. The data soon became hard, undeniable truth. First, temperature. Pilots flying these altered P-51s reported a consistent, vital drop in high-altitude engine temperature, a staggering 15 to 17 degrees Fahrenheit lower than standard configurations. This margin, seemingly small on paper, was the difference. 25,000 feet up and thin, cold air, between pushing the throttle to the absolute limit and throttling back to avoid catastrophic engine failure. Second, time of climb. With refined airflow and reduced drag to the radiator duct, the Mustangs now clawed their way to combat altitude up to 12% faster. This meant pilots could scream above their German adversaries more quickly, securing the single most important advantage in air combat, the altitude high ground. Third, and perhaps the most powerful metric of all, survivability. In one squadron alone, the kill ratio for Tex Harper's modified aircraft soared, jumping to an astonishing 3-to-1 margin over 6 punishing weeks of air combat. The pilots flying them were the same men. The guns hadn't changed their fire rate. The fuel was the same high-octane mix. The only difference, the single fulcrum point in the sudden shift of air supremacy, was a tiny, reshaped internal airflow duct and the audacious mechanic who dared to cut it open. Soon, the legend of the modification spread like wildfire, carried not by official communique, but by whispers across the taxiways. It transcended Tex's original unit. Mechanics at neighboring airfields across East Anglia established an underground network, writing urgent letters home asking for thin sheets of scrap aluminum, smoother tools, and even homemade sealants to mimic the unauthorized improvements. Some, desperate for the edge, cannibalized parts off grounded aircraft, stripping them to copy the slick, angled internal vanes. Unofficial blueprints began circulating on stained napkins, dog-eared notepads, and pages torn from official aircraft maintenance logs. There was no centralized design. Each mechanic brought their own flair to the concept, but they all owed the spark of rebellion to Tex Harper and his original rule-breaking experiment. Still, the top brass maintained a willful, strategic blindness. Commanders higher up were certainly aware something miraculous was happening in the skies. But with kill ratios improving and mission success rates climbing into the stratosphere, no one was eager to pry open the hangar doors. As long as the planes kept flying fast and the pilots kept coming home, any potential violations were quietly ignored. That grace period shattered the moment a rigid colonel from the 8th Air Force Command arrived for a scheduled inspection. This man, steeped in regulation and protocol, was doing a routine walkthrough of maintenance operations when I caught the exposed belly scoop on AP-51. It had been opened for a routine coolant line check, and inside, visible to the naked, outraged eye, was a non-standard ductwork. Angled metal vanes, polished smooth, clearly fabricated, and entirely absent from any authorized blueprint. His face turned instantly crimson. Within minutes, the hangar was echoing with his demands. Who authorized this modification? Where were the engineering documents? Why hadn't North American Aviation, the manufacturer, been consulted? Tex was called in. He didn't lie. He explained simply and clearly what he had changed and why. He showed the damning evidence. Temperature logs, critical climb rate comparisons, and stacks of confirmed combat reports. Other mechanics backed him up instantly. Pilots, including some of the most seasoned aces in the 8th, lined up to speak on his behalf. Captain Red Lansing stepped forward, addressing the colonel with a sentence that cut through the noise of regulation and fear. "Sir, you can fly it cold or die hot. That's the choice." The colonel did not reply directly, but he made a call that evening that rattled the foundations of the engineering command. 2 days later, a high-priority team of engineers from North American Aviation arrived on base, armed with blueprints, sophisticated testing equipment, and a list of urgent, skeptical questions. They spent a relentless week examining Tex's unauthorized modifications. They ran complex airflow tests, took detailed photographs, and installed pressure sensors inside the modified ducts. And when the data came back, the verdict was not only clear, it was revolutionary. Tex Harper's design didn't just work. It was brilliant. The angled, internal vanes helped stabilize the turbulent airflow, dramatically reduce drag, and increase the pressure across the radiator core. This improved heat dissipation and, crucially, allowed the elusive merited effect to kick in consistently under combat conditions, delivering a small but measurable thrust gain. It was exactly what the original designers had hoped for, but failed to achieve in 2 years of sterile lab development. In short, Tex had done in a freezing hangar what an entire team of engineers couldn't pull off. He had traded a potential court-martial for a defining secret of Allied air power. The recommendation was undeniable. It was a victory forged not in office, but in the heat and chaos of a field hangar. North American, recognizing genius, swiftly incorporated Texas modifications into blueprints for the next generation, the definitive P-51D Mustang. This variant, born from desperation and scrap metal, will become the undisputed champion of the skies. For Tex Harper, there was no reprimand, no threat of a court-martial. Instead, there was a quiet, earned respect. He was technically promoted, later receiving a field commendation for innovation under fire, but Tex cared nothing for stripes or rank. All that mattered were the faces of the young men walking back from the flight line. The fact that his scrap metal intuition was bringing more of them home, that was the only reward that counted. The pilots knew who to thank. One of them, using a pocket knife, etched a simple phrase for Tex, who made her breathe into the access panel of the Mustang. By the spring of 1944, Tex's one secret internal vein system was an open legend across the bases of East Anglia. Dozens of P-51 Mustangs now carried a modification, flying higher, fighting longer, and returning from deep penetration missions with zero overheating issues. But success, particularly unauthorized success, casts a long shadow. The moment a visiting general, steeped in rigid regulation, spotted the unauthorized ductwork snaking beneath the cowl of a pristine Mustang. The fragile field truce was shattered. His reaction was not curiosity. It was immediate, icy fury. Military aircraft were sacred engineering. Modifications, especially to structural components like a cooling system, were heresy. The rules, the brass roared, existed for safety, for consistency, and for accountability. Within the hour, the order came down like an axe blow. Stop work. All aircraft fitted with the unauthorized modifications were grounded immediately for review. No further changes without written engineering approval. For Tex, this was more than professional insult. It was a potential death warrant signed in triplicate. 1P-51 had already been prepped for the brutal long-range escort mission to Berlin the following dawn. Its pilot, Lieutenant Jack Reynolds, stormed into the maintenance tent, his flight helmet gripped tight. "You're telling me I have to fly a stock bird?" he demanded, disbelief sharp in his voice. "Orders from upstairs," someone muttered, staring at the floor. Reynolds locked eyes with Texas. "Tell me this is a mistake." Tex, the man who gave him life, could offer no defense. That night, a quiet tension settled over the hangars. Mechanics whispered grimly about what might happen. Some feared Tex would be court-martialed. But then, the men who flew the missions pushed back. It started not with a shout, but with measured defiance. Captain Red Lansing, still wearing his sweat-stained flight gear, walked into the command office. He faced the squadron leader, his voice level and utterly firm. "Sir, I don't care what's written in the tech manual," Lansing stated. "Those modified planes keep us alive. You put me in a stock model above 20,000 feet, and I am a sitting duck." One by one, the other pilots followed. They offered quiet but firm testimonies. They were not engineers. They didn't understand airflow ratios or radiator efficiency, but they knew results. And the results screamed that Tex's design worked. The squadron leader, caught between rigid protocol and the stark reality of combat attrition, sent an urgent formal request. Delay the grounding until the review was complete. The high command conceded, but their approval was brittle. They demanded validation, a pilgrimage by North American aviation's own prophets of efficiency. Within days, the fragile ecosystem of the forward airfield was invaded by two senior engineers. These were men of the drafting table, clad in pristine wool coats and horn-rimmed glasses, utterly alien to the raw, visceral urgency of the front line, the eternal stench of mud and exhaust fumes. They swarmed the modified Mustangs, quiet as surgeons. Calipers glided over contours Tex had hammered by hand. Detailed measurements were taken. Factory specifications consulted. Every slight curve and reshaped duct recorded. The tension hung thick, but their faces remained impassive, until the instruments spoke. Using portable field rigs for wind tunnel simulations and pressure tests, the numbers started stacking up. The engineers exchanged glances. The silence shattered. "It's effective," one conceded. The words tight with professional shock. Asterisk, highly asterisk effective. Weeks of defiance, risk, and rumor were instantly verified. Texas' crude, field-tested modification was not the work of a rogue mechanic. It was sound thermodynamics. His reshaped duct delivered smoother internal airflow, spiking the internal pressure and dissolving the critical heat dissipation problems plaguing the P-51. It was engineering truth, forged in scrap metal, not etched on a blueprint. The engineers moved beyond mere approval. They became apostles of the Texas fix, compiling exhaustive schematics and sending them back to California via secured channels. The great institutional confrontation did not conclude with disciplinary action. It ended in undeniable progress. Tex was summoned to the squadron office. The colonel who had once promised him a severe reckoning now held a crisply typed letter. It was a formal commendation for field innovation. It was a promotion, yes, but the true prize was the official acknowledgement that his dangerous gamble had saved countless lives high above the Reich. Tex simply nodded, folded the document with mechanic's precision, and tucked it into his breast pocket. He had no time for ceremony. He turned back toward the cloud of the hangar, the long line of ailing Mustangs waiting for their next chance at survival. By late March 1944, the defiance of one man had become institutional decree. North American aviation didn't merely validate Tex Harper's design. They consumed it. Thousands of miles away in the sterile light of California hangars, engineers drafted formal revisions for the P-51's cooling system. The official technical language, dry and clinical, labeled it the internal airflow smoothing and compression retrofit. But among the men who flew and maintained these silver steeds, it had only one legendary title: the Texas Fix. The ultimate testament arrived with the P-51D, the quintessential long-range version of the Mustang. Tex Harper's radical ideas were now permanent features of the most effective fighter aircraft of the war. New airframes poured off the assembly lines bearing the optimized duct shapes, smoother flow paths, and subtle, life-saving design tweaks conceived in a muddy French airfield using scavenged metal. It was a twist history had not forecast. A mechanic in dirty coveralls, lacking a degree or official clearance, had proven superior to the collective theoretical genius of an entire corporation. He solved the high-altitude performance choke point, reshaping the war's most crucial long-distance escort fighter. The Mustang's newfound ability to shepherd bombers deeper into the Reich without overheating, to climb faster than the Luftwaffe's finest, and to survive brutal, sustained dogfights high above the clouds, all of it owed a debt to the innovation that should never have existed. The pilots felt the difference instantly. The new Mustang sliced to the high altitude with lethal grace they never possessed before. Tighter in the climb, cleaner in the turn, their modified engines maintained stable temperatures even under maximum boost. This wasn't just an engineering footnote. It was a margin of life. It meant fewer aborted raids, fewer wrecks littering the unforgiving field of Europe, and a greater chance that the young pilot climbing into the cockpit would see his next birthday. By June 1944, when the Normandy invasion shattered the morning quiet, every Mustang squadron relied on the gospel of this cooling redesign. The man who birthed it, Tex Harper, shunned the spotlight. He didn't file the official ARS, nor did his name appear on the final blueprints. Yet, among the ground crews, he became a quiet deity, a legend cemented by two simple words. When the first P-51D arrived with a factory-installed duct, Tex simply ran his hand over the curve, nodded once, and said, "They got it." For Tex, credit was irrelevant. The idea, born of necessity, instinct, and a little rule-breaking that could have easily led to a court-martial, had finally saved hundreds of lives. Pilots cared little for the source. They only knew their birds flew cooler, flew better, and brought them home more often. This rare twist, from rogue fix to official doctrine, was a stark reminder that the front lines of innovation are often found in frozen hangars, under leaking engines, in the hands of men who trust what they feel more than what they're told. This victory of innovation laid the foundation for the deadliest missions yet. March 6, 1944, the U.S. 8th Air Force launched its ultimate gamble, Berlin, the beating black heart of the Reich, the epicenter of Nazi industry and propaganda. The Germans knew they were coming. Hundreds of B, 17 flying fortresses and B, 24 Liberators headed east, guarded by the long reach of the P-51 Mustangs. The test was brutal. The air corridor above Berlin was the most heavily defended space in the world, bristling with the Luftwaffe's elite. Veteran pilots flying aggressive swarms of Focke-Wulf 190s and Messerschmitt Bf 109s. The initial silence was a terrifying calm before the storm. Just west of the capital, the German radar alarm screamed. The Luftwaffe plan was pure attrition. Hit the bombers hard and fast before they could even reach their target. Striking above 25,000 feet with a cost of air superiority was measured in shredded aluminum and lost oxygen. But the aerial dominance gained in the skies over Germany merely paved the bloody road for the grinding battles of the late summer. The focus shifted from the thin air of the Reich to the choked hedgerows of Normandy, where men like Lieutenant Karl Hartmann fought for every meter of scorched earth. It was August 1944. The American breakout was underway, and the desperate German High Command launched Operation Luttich. Their objective was audacious: drive straight through the American lines and retake Avranches. Standing directly in their path, holding a crucial crossroads under relentless fire, was Lieutenant Karl Hartmann S. tank crew. Inside their Sherman, coated in dust and spent brass, the suffocating reality of the infantry support mission was clear. Lieutenant Karl Hartmann, the commander, scanned the Trieline, sweat stinging his eyes. Behind him, Earl Bishop, the gunner, waited, knuckles white on the traverse wheel. Every second felt like an eternity for James Ortega, the loader, who stacked fresh rounds, the steel casings too hot to handle barehanded. Down in the hull, Tony Vitelli, the driver, kept the engine idling, ready for the sharp order to advance or retreat. They knew this crossroads near Mortain was where the line would hold or where it would break. If they failed here, the only report read by men like George Marks would be a devastating final AR. Above the Reich, the air was poison, a realm where friction and extreme cold turned complex machinery into a deadly liability. But this time, the Mustangs did not yield to the elements. They did not lag, did not overheat, did not crack under the strain of high-altitude escort. They stayed tethered to their bombers. And they hit back. The sky tore open as dozens of savage dogfights erupted. Unshackled from the constant management of internal temperature, American pilots pushed the powerful Merlin engines past their documented limits. They executed blurring, high-G turns and slashing attacks, maintaining ferocious aggression deep into the heart of German formations. They could stay in the fight longer, climb higher, and dive faster than ever before. Captain Red Lansing, flying one of Texas's early field-modified Mustangs, became legend that day. In a brutal 10-minute stretch near Potsdam, he decimated the enemy, claiming 3 confirmed kills, 1 Messerschmitt and 2 Focke-Wulfs. His testimony, later formalized in the AR, echoed the sentiments of the entire squadron. The engine didn't even flinch. I was climbing at 30,000 feet and still had power in reserve. They tried to outclimb me, and they simply couldn't touch me. Other pilots confirmed the crucial difference. The cooling system improvements allowed for extended, high-power climbs previously considered suicide. No overheating, no debilitating boil-off, just raw, reliable power delivered on demand. By mission's end, the numbers were devastating. 69 German aircraft had been confirmed destroyed, with scores more crippled and damaged. The Luftwaffe had suffered a catastrophic blow, an aerial defeat from which it would not recover quickly. Most stunning of all, nearly every American bomber made it home. The Berlin raid was more than just a strike at the heart of the Reich. It was the undeniable proof that the United States had achieved air superiority, even over the most heavily defended city in Europe. While headlines back home celebrated the courage of the flyers and the precision of the bombardment, few understood the true engine of that victory. It wasn't just the robust Merlin or the long-range fuel tanks. It was airflow. It was cooling. It was a mechanical ability to fight at 30,000 feet without the machine turning on its master. And for that, the credit belonged to a man who never left the ground, a man who worked in the unforgiving chill, grease staining his hands, without a commission or official recognition. Tex Harper. That day over Berlin marked a defining pivot point. Air combat was instantly redefined. Speed and firepower were no longer enough. You needed reliability. You needed altitude. You needed the edge. And because of Tex, the P-51 Mustang had seized it. What Tex Harper left behind changed the geometry of the skies. After Berlin, the Mustang, already respected, became universally feared. German pilots recognized that sleek silhouette instantly and dreaded it. The P-51 was no longer merely a fast escort. It was an apex predator, a high-altitude killer designed to fly farther, climb faster, and fight longer than anything the Luftwaffe could throw at it. The secret to that revolutionary leap wasn't a strategy session or a factory breakthrough. It was a mechanic with a hacksaw, working in a cold hangar, who simply refused to accept good enough. Tex Harper never graced the headlines, never gave an interview, never claimed credit. After the war, he quietly returned to Oklahoma, opening a small engine repair shop. Most of his customers never knew he had once re-engineered the sky above Europe. But his legacy, the principles behind his cooling mod, became the blueprint for aviation dominance that lasted decades. The whispers of the P-51's streamlined performance echoed far beyond 1945. The practical application of the Meredith effect, that revolutionary insight into airflow management, became the bedrock of post-war aviation. Engineers studying the nascent power of jet propulsion looked not just at rockets, but borrowed core lessons from the harsh, improvised ductwork perfected on Texas battlefields. The impossible idea that cooling systems could contribute to thrust, rather than just bleed energy managing heat, was carried forward into the jet age. In the freezing skies of Korea, the sleek American F-86 Sabre owed a hidden technical debt. Its refined airflow engineering traced its lineage, in part, directly back to what Tex Harper proved in the field. Even today, the stealth fighters moving like ghosts through modern airspace, with their carefully managed thermal signatures and intricate internal ducting, are built on the silent promises made under the fuselage of a 1944 Mustang. But perhaps the most enduring legacy of Tex Harper wasn't found in blueprints, patents, or polished museum plaques. At the National Museum of the United States Air Force in Dayton, Ohio, stands a perfectly restored P-51 Mustang. It is a stunning ghost, shining aluminum skin, defying invasion stripes painted across the wings, the name Lucky Lady stenciled proudly beneath the cockpit. It is a monument to speed and audacity. But walk past the velvet ropes. Crouch down, deep beneath the belly, just inside the raw, hungry edge of the radiator scoop. There, where the casual visitor never looks, you'll see 3 words etched in small, careful letters. For Tex, who made her breathe. No ceremony, no parade, no statue, just a quiet, profound acknowledgement from one generation of warriors to the man who helped them survive the inferno. This is the kind of legacy that outlives medals. They say history is written by the victors, but sometimes the most important truths are written not in ink, but in grease, not in soaring speeches, but in silence. Tex Harper never fired a gun in anger. He never pulled G's in a dizzying dogfight or bailed out of a burning cockpit. Yet without him, an entire generation of pilots might not have returned home. He broke the rules. He ignored procedure. And in doing so, he saved lives, not through brute force, but through surgical focus, not through blind obedience to orders, but through quiet, intuitive understanding. He saw a problem waiting to kill men, and instead of waiting for a committee to convene, he fixed it. That is not merely engineering. That is courage under fire. Lieutenant Jack Reynolds, the pilot whose story opened this account, gave an interview years after the war had faded. He was an older man then, white-haired, his voice quiet. When asked who his hero was, he named no general, no famed ace. He said, "People talk about aces, but the man who saved my life wore oil-stained coveralls and never left the ground. I don't even know if I ever saw his face, but I remember how that engine held together when I needed it most. He gave me altitude, and that altitude gave me a chance to come home." There are thousands of stories like that from the war, stories that were never told or were nearly forgotten. They remind us that victory is never just about firepower or sheer bravery in the sky. It is also about people like Texas, the ones who work quietly, who solve impossible problems, who build things better, Not because they're ordered to, but because it is right. Not all heroes fly. Some of them kneel beneath a Mustang in the dead of night, shaping cold aluminum with frozen hands, thinking only of the pilot who will rely on that engine tomorrow. And thanks to Tex Harper, that pilot always had a better chance of seeing the sun rise again.